All right. Welcome and good morning to everyone. Welcome to my Euclidean Geometry free Zoom lesson. My name is Tolani, popularly known as Mr. X, and I'm excited to have you guys here with me. We're going to be doing beautiful things today. We're going to be doing a lot of things to do with Euclidean geometry as it were. But I'm excited to start off with this part, I'm very excited to start off with what's going to happen in the next coming couple of weeks before we start our discussion today. So in the next coming couple of weeks, I'm going to be holding a massive revision program for mathematics and physical science. It will be an 8-hour-a-day revision program. Each subject will be 3 days. And so you're looking at 24 hours for one subject face-to-face with me. Okay, so for example, let's say we start on Monday, 8 hours, Tuesday, 8 hours, Wednesday, 8 hours. That's for one subject. And again, the next week of it will be the other subject, 1,200 for each particular subject. So here's what you can expect. Tackling of high flyer questions, past exam papers like no man's business, focusing on questions with lots of marks, how to deal with the problematic problems, which is what we're having right now, Euclidean geometry, focusing on most challenging topics, exam tips, obviously, and time management in an exam, and obviously intense assessment and feedback. If you're interested, right now I'm taking bookings. If you're interested, and remember, this is just for the whole of South Africa. If you're interested, all you simply need to do is contact me. That's my number, or 739748498. Let's get that mark. Let's get that beautiful distinction that we're looking for. Check my Instagram page, Mr. X Maths Science, and also my Facebook page, Beacon of Light Mathematics and Science Center. It's an icon with a simple B. So just right now is booking, talk to me, and we take it up from there. All right, that's done. I'm going to disable my video, but I'm going to make sure that I'm here while I teach you right there. Okay, so now we're going to do the questions. Here's what we have, and this is our first question. What I need you guys to do is to write these things down, right? The title of the question, 2016 March, paper 2, question number 8. And then Tina, we started off here. As usual, if you have any question, all you need to do is just lift up your hand through this platform. So there is an icon that says raise hand, look for it there. You should be able to lift up your hand. And then when you have lifted up your hand, I will unmute you. Then we can start talking within ourselves. All right, let's begin on that one there. We are doing 2016 March paper 2, and that's question number 8, Euclidean geometry. Let's start. In the diagram below, KT is a tangent to the circle. K is parallel to the chord. MN on the other side cuts the circle at L. Triangle KML is drawn. M2 is equal to 90, is equal to 40, and MKT is equal to 84. That's what we have currently on our situation. Right, what's important about Euclidean geometry is to be able to look at a diagram, then break it down into pieces. Look at a diagram, then break it down into pieces. So what's happening here? I have M2. So I'm given M2. I want to annotate that one there. Make sure it looks clear. That's my M2, and M2 is equal to 40. I have K1 and K2, the combination of the two guys, and they give me 84. Fine. I've got parallel lines, KT, and got NM also being parallel, and that's very important. Now, we begin now the question. Determine, giving reasons, the size of angle K2. So I'm looking for K2 here. If I look at K2, it starts from this particular tangent, I was told that, and it touches the chord KL. And then if I look at chord KL, right, I'm talking about K2. If I look at chord KL is subtending M2 at the circumference. So I want to look at this clearly. If I look at chord KL, it's subtending M2. And by the way, subtending means made from. So when I say M2 is subtended by KL, all I'm simply saying is that this M2 is made by a line from K and a line from L. Makes sense. A line from K, there it is, there it is, there it is. And the line from L, there it is, right there. It makes M2 as you see it. And the question says, find K2. I want to write this down. So K2 for me will be equal to M2 will be equal to 40 degrees. And what's my reason? My reason is tan chord theorem. 8,11, write that one down. Let me go quickly and finish up all these questions. Then after this, we can write. Let's try N1. I'm ready for N1. Okay, so that was K2. Keep that in mind. I'm ready for N1. Let's discuss something here. Now, looking at what I'm looking at, N1 is subtended by a line from M and a line from L right there. So a line from M, there's my line from M, and the line from L subtends N1. I'm also clear that K1 is also subtended by ML. So for me, N1, okay, K1, okay, they are both subtended by the same chord, both made by the same chord. So what does that mean? It means N1 will be equal to K1, and my reason is angles in the same segment. Let me write it like this, same segment. So I learned that. So N1 is equal to K1, angles in the same segment. But look at what I'm looking for. I'm looking for N1. I don't know what K1 is, but this is what I know. I know, judging by what I see, that K1 plus K2 is equal to 84. I can see that. Okay, but then did I find K2 in the previous question? Yes, K2 is 40, K1 is equal to, at the end of the day, K1 will be equal to 44. But am I looking for K1? No, I'm not. I'm looking for N1, but N1 is K1. So N1 again will be 44 degrees. That's 8,12. I still emphasize, it's important to keep looking at what you're going through. Look at these particular angles and how they relate one to another. Without knowing the theorems, it's almost impossible to understand what's going on. Let's try T. I'll write this guys down. Write this one there. Let's try T and see if we can get T for ourselves, and that's 2 marks. So we're looking for T right now, and that's a good 2 marks. I'm going to take this out in the next 10 seconds or so. Write this one down. So I'm looking for T. While if you have finished writing this, just start thinking about T. All right, there we go. It's gone. I look at T. I want to deal with T. So there's T right there. Okay. I can tell you this. Look at this. N1. There's N1. N1 for me becomes equal to T. I have to have a reason why I say that. It's equal to 44 because N1 from the previous question is 44. Alternate angles. And when I say alternate angles, I must say KT is parallel to NM. Look at this. If you look at N1, the position, and T, the position, don't forget that KT and NM are parallel. So that makes N1 and T, in this case, become equal to each other, alternate angles. That's 8,13. Let's try the next one, 8,14, a good 2 marks. I'm looking for L2. That's what I'm looking for. I'm looking for L2. Okay, let's discuss. Look at this particular triangle here. If you're looking for L2, let's just make sure I make it annotate. It looks proper there. So there we are, there we are. Okay, so let's deal with that particular scenario together. So I'm looking for L2. That's what I'm looking for. So I'm looking for this angle here, which is L2 right there. Now, if I consider triangle, this one that I'm looking at, which is KLT. Notice that L2 is an exterior angle. It will be equal to K2 plus T. I want us to look at this. So L2, there it is right there. L2 is equal to the sum of K2 and angle T. And that one is exterior angle of a triangle. So the sum of two interior angles is equal to the exterior angle. So L2 is called K2 plus T. K2, I know it from the previous questions, 40, and then T1 is 44. At the end of the day, that means that L2 is 84 degrees, just like what you're looking at right there. So I see that. So at the end of the day, L2 is equal to 84 degrees like that. Okay, let's keep going. I'm on my next one there. Make sure that we understand this properly right there. All right, let's try the next one and see how far we can go. We're trying the next one. We are seeing how far we can go. Let's try the next one. And I think for me, the next one is going to be L1. So I'm looking for L1 this time, and I'm looking for L1. So let me take this out. Okay, so here's what we're going through right now. I'm looking for L1. Okay, there's L1, all right. Anything that I can see, who subtends L1, NM, anything else subtended by NM? No, I don't see it. Is there another method of looking at things? Yep, there is. Let's try this. Okay, let me see. If I was to do the whole triangle thing, and I'm gonna move this up here, check this out, there it is. And then maybe I can move this one as well here, and then have this as a triangle. All right, look at that. Beautiful triangle. Let's give the triangle a name. We'll give it the name KLM. So what's happening in triangle KLM? Okay, K1, I see that, okay, tick, plus L2, L1, which is this whole angle, all right? So plus L2 plus L1 plus M2, that whole angle there should be equal to 180. And I must have a reason, angles in a triangle. Now, I know what I know. K1 is 44 from the previous questions. L2 from the previous one is 84. L1 is what I'm looking for. M2 given, it's 40 is equal to 180. You do your maths properly, L1 is equal to 12 degrees. And that's your answer for 8,15. Now, obviously, guys, I need you guys to interact with me and let me know where you're struggling so I can help you out. All you need to do again is just lift up your hand and I should be able to see you. Otherwise, write this one down. We are moving on to something else. All right, moving on to our next question. So this is 2016 March paper 2, and that's question number 8. So I think, Chloe, you asked me a question here to say, would you be wrong if you say that if N1 is equal to K1, okay, N1 is equal to K1, and you're saying N1 is equal to K1 because they are subtended by the same arc? Not necessarily, you wouldn't be wrong, still same arc, or in this case, you can say same chord. Right, I'm taking this out now. I'm moving on to my next part of my screen right there, and we'll move on. Right, guys, again, I emphasize that please ask me as many questions as possible. 8,2, we continue with the same question. This time, we have a different diagram. In the diagram below, I read AB and DC are chords. I see that AB, there it is. DC are chords, there it is. E is a point on AB such that B, C, D, E. I have to follow that guy through. So who is he? B, C. So let me use this particular part. B, all right. C, B, C, D, E. There is a parallelogram. That's very important. Now, obviously, we need to know the properties of shapes. we need to do. So for a simple one like a parallelogram, I want you to know that the opposite sides of a parallelogram are parallel. So what do I mean? I'll tell you that EB is parallel to DC. I can also safely tell you that ED is parallel to BC. That's what I can tell you. So that's fine by me. It's a parallelogram. Okay, then what? Now, again, I need to tell you that the opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. What do I mean? E, which is 108, will be equal to C. I need to write that thing down. So C is equal to 108, and that's a reason. The reason is opposite angles of, let me write my shortcut, parallelogram. They are all equal. So C already is 108. Fine. Let's continue with the question. So it says DEB is 108. I see that. And it says DAE is 2x plus 40. Question, calculate, giving reasons, the value of x, and it's 5 marks. So I'm looking for x. I think I see something else as well. Look at this one, interesting one. Look at this shape, okay? I'm going to continue on that one, and I'm just going to add the green part there. Notice something as well. Notice that A, B, C, D is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. Just so you may know, a cyclic quadrilateral is a four-sided shape whose points are on the circumference. Four-sided shape in a circle whose points are on the circumference. So if I look at the points on the circumference here, I'm looking at A, I'm looking at B, I'm looking at C, I'm looking at D. These points are called concyclic points. They are all on the circumference. As you can see it, A, B, C, D is a cyclic quad. I'm looking for X. What do I know about cyclic quads? I know that angle A, which is 2x plus 40, plus angle C, which I already know, is equal to 180. My reason, opposite angles of a cyclic quad. Okay, A, 2x plus 40. C, I know you, 108. The rest is algebra. I am looking for X. So 2x at the end of the day becomes equal to 32 after doing my maths. X is 16, a good 5 marks. So that's what you have. X is equal to 16. All right, so you need to know the properties of a parallelogram. The properties of a parallelogram, and as you can see it for yourself, I'm saying to you that the opposite angles are equal for a parallelogram, but at the same time, I'm also saying I have a cyclic quad, and the opposite angles of a cyclic quad definitely are supplementary. Write this down. Let's try our next question. I want to move on to my next question. So I'm just going to be doing questions. Then eventually towards the end, I'll give you stuff to try on your own as well. Obviously, you need to try something, and that's very important. All right, somebody's saying, can I explain 8.2? That's Mahlodi. No problem. So here's how it goes. All I was simply saying to you is that you're told, and that's very important, that BDCE, the shape that I put in red, BCDE rather, BCDE, the shape in red is a parallelogram. And because I know that it's a parallelogram, I'm learning something that the opposite angles of a parallelogram are equal. So I'm expecting that E, which is 108, is equal to C. So that was my first statement there. C is 108, and my reason, opposite angles of a parallelogram. It's not 11, guys. This is just parallel lines. Parallelogram. And then I said ABCD is a cyclic quad. I follow it ABCD, all right? That wall shape is a cyclic quad. I already know what C is. 108. I know that A is 2x plus 40. I know a theorem that says the opposite angles of a cyclic quad are supplementary, meaning that they add up to 180, suggesting that A plus C in this case would be equal to 180. The rest is algebra. And I see that right there. Okay, let me take this out, family. Here it goes. Let me try my next question so that we can be able to see what we are doing. Let's try our next question right there. All right, let me move here. 2016 Overbeck District Prelim Paper 2, and that's question number 9. Want you to work with me on this one. So write the title, we will do the question together. Write the title, we'll do the questions together. All right. So somebody's asking, say, as long as all the sides lie on the circumference, we can assume that the shape is a cyclic quad. Yes, please. As long as all the sides lie on the circumference, the shape is a cyclic quad. I will even show you on this question. All right, let's begin. In this particular question, thank you, Lindani, for answering that as well. In the diagram, ABCD is a cyclic quad. Let's follow it. Let's have our colors. In the exam, guys, if you can have color pens there where you can be able to annotate properly, I'd like that. So you got ABCD. So I'm going to put it in red. So I need to make sure that it comes out nicely. A, then there, that one there, that's going to be my other straight line. And then that one there, I'm definitely making sure it comes out well. And that one there. So that's what you have. Look at it. All the lines, all the points are on the circumference. Fine. Question number 1. B. Okay, let me read. In the diagram, ABCD is a cyclic quadrilateral in the circle having center O. Okay. Tangent. Take note of these words. Tangent cyclic quad. Tangent FC meets AD produced in E. So tangent FC meets AD produced in E. Radius AO, okay, and chord AC are drawn. ABO is equal to 38. I see that. That's ABO, fine. CBD is also 25. That's given. Question, BAD, calculate giving reason. So I have to follow what BAD is. So here's my point. BAD. So I'm looking for this wall angle there. Now, notice that O is the center. So BD is a diameter. And the angle that we're looking for, this one here, BAD, is made from a line from B and a line from D. In other words, it's subtended by the diameter. And what do I know in math? I know that angles subtended by a diameter at the circumference, they're equal to 90. We usually write this as angles in a semicircle. That will be my reason. So BAD is 90, angles in a semicircle. That's what I have. All right, I'm going now to my next one. I'm looking for AOD. AOD. Okay, let me see who AOD is right there. So I'm looking for AOD. Let's work it out together. So that's AOD. Looks like it's the center angle. All right, let's discuss. AOD, I look at the diagram as usual. I think AOD is made by a line from A, there you are, and a line from D, and it's at the center. All right, AOD made by a line from A and a line from D, and it's at the center. Fine. I look at 38. It's also made by a line from A and a line from D, but it's at the circumference. There's a theorem. I'm looking for AOD. There is a theorem, AOD. The theorem that says that angle at center, AOD, is twice angle at circumference. So I'm expecting AOD to be 76 degrees because angle at center is twice the angle at the circumference. It's important to notice who subtends who makes who, and what's happening right there. That's what you have. Angle at center, twice angle at circumference. Let's try CDE. Ready for CDE, all right? So don't forget these other numbers that you found already. CDE, that's what I'm looking for. I've got to go and draw who my CDE is. Follow it, CDE. I think for me, it's this angle. It's like an outside angle. All right, CDE, I think I can get it. CDE is 63. Come on, how did I get 63? Look at it. This whole angle, added together, 38 and 25, gives you 63. And CDE is an exterior angle of a cyclic quad equal to the interior opposite angle. CDE, exterior angle of a cyclic quad equal to the interior opposite angle. So I'm gonna write my information together now and see if I'm winning on this one. Follow my lead. So in this case, I will say to myself, CDE is equal to 63, and Y, exterior angle of cyclic quad. Remember they told you AB, CD is a cyclic quad, so you would know that exterior angle of a cyclic quad is equal to the interior opposite angle. All right, I'm on DCE now, so I'll keep working. Let me see what I'm looking for. DCE, follow the lines. DCE, I'm ready. DCE, which is this particular angle here, DCE. Okay, judging by what I'm looking at, DCE, I think for me, let me make it maybe into a bit of a black, darker color, DCE. Now, FCE is a tangent, so that's fine. And this angle, DCE, is drawn from the tangent, and then it touches the chord CD. CD happens to subtend 25 at the circumference. I hear tan chord. So DCE as an angle is equal to 25 degrees. Why? Is because of the tan chord theorem. So you can see that there's an angle, this one touching the chord. Then you ask yourself, the chord CD, who do you subtend at the circumference? I subtend 25. So CDE is definitely, that angle DCE rather, is definitely equal to 25. And my reason is tan chord theorem. Let's try the last one, ACD. As usual, guys, if you have any questions, please do not hesitate to ask me. I will definitely help you. If you have any questions, do not hesitate to ask. I will definitely help you. All right, let's try our next one together. Let's try our next one together and see how far we can go. All right, I'm ready for my next one. I'm taking this out. The next one then says ACD. I'm hoping that you're thinking about it. ACD. So I need to see who ACD is. I think it's this angle, Mina. That's ACD. Who makes this angle ACD? AD. Or you can say the arc AD if you want, but I prefer the chord AD. A line from A and a line from D makes this particular angle that I'm looking for. I noticed something as well. A line from A and a line from D makes 38. So I now know ACD should be equal to 38 degrees. My reason, angles in the same segment right there. But you know what you could also do? Remember this angle here is 76, the angle at center there. You could also simply say as a reason, this angle is 38. This one that we're looking for is 38 because angle at center is twice the angle at the circumference. So that's still fine. Angle at center is twice the angle at the circumference. All right, so that's angle at center, twice angle at circumference. All right, you guys can ask me questions. It's a question that just came through. I don't understand it. I need maybe clarity. Say, why can't we use triangle CAD? CAD for which one? You help me out. You can just lift up your hand, and then maybe I can hear what you're saying and understand all that. Okay, so ACD is 38 angles in the same segment right there. All right, I want to unmute you. I've seen your hand, O. I think your name is written as O right there. So let me ask to unmute you. Go ahead.
Morning, sir.
Morning, hi.
So for the 10 chord theorem on 9.1.4, we use triangle CDB, right?
We used triangle, talk to me, CDB, yes.
Why couldn't we have said triangle CAB, and then for the angle that we're looking for, the answer is the whole of angle B?
The whole of angle B. And we're using triangle what?
CAB.
CAB, right? And then the whole of that angle is angle
Becomes
B.
10 chord.
All right, let me show you. Look at this. This angle touches this chord. So CD is subtended at 25, right?
Okay.
Fine. Then you suggesting to me that why can't we use the whole of angle B? The whole of angle B is not subtended by CD. It's subtended by AC. Do you see that now?
Yes,
all right, beautiful. So that's a beautiful question right there. All right, I'm ready. I can just mute you now. Thank you so much. Let's move on to the next question as a family. I hope you guys have written all of that. We're now going to our next question. All right, beautiful. Here's our next question, 2015 Western Cape. All right, it's a beautiful question. Mpho, you raised your hand and I want to unmute you right now. So let me look for you. There we go. Okay, found you. All right, talk to me. Is it the previous question that we're talking about?
Yes.
Let me drop it.
Yes, sir. So
yes,
on 9.1.5, am I correct to say that ACD, ACD is equals to 38 by using the Tancourt theorem?
ACD is equal to 38.
Because we know that DCE it's 25, so we can minus 63 from 25 to say, and then say Tancourt theorem.
Okay, so this is what I think you want to say to me. So this whole angle here, this whole angle is actually 63. This whole angle right here is 63.
Yes, sir.
Right, because it's Tancourt theorem, which is what UO was asking about there. So that's all 63. And then you're saying to me, say, since we know that, then we can just simple subtract, and then 63 minus that 38 will give me my 25. Is that what you're saying? Okay, I think she's muted herself. Okay, fine. Let me look for her again. Okay, lift up your hand again. I really didn't recognize your name. Percy, in the meantime, go ahead.
Morning, sir.
Morning, hi.
How are you, sir?
Great, talk to me.
I need to establish that ACD is equals to ABD, which is 38.
So this is 38. Okay, I hear where you're coming from. All right, and then this whole angle is now 63. So this one automatically becomes 25. I agree with you.
So is it okay to say the reasoning is angles subtended by the same chord and then write which chord they're subtended, or must we say angles in the same segment?
You can also say angles subtended by the same chord or angles in the same segment. Really doesn't matter. Either way, it's going to be fine. Angles subtended by the same chord, or angles in the same segment. All right.
Okay.
Thank you guys for that one. All right. Thank you. You can mute yourself. Thank you guys for that one, right? And I think Umashodi already got what he or she was looking for right there. Mpho, You still have your hand up. I'm going to ask to unmute you. Go ahead.
So I was asking if I were to say the reasoning would be 10 chord, am I correct?
Yeah, that would be 10 chord eventually, yes. And then, but you need to do the subtractions properly. And I would agree with you. That would be fine for me. I'll take that through. Right, mute yourself and let's go to our next one. 2015 Western Cape family, 2015 Western Cape. That's our next question right there. Interesting. Here we go. In the diagram below, A, B, C, F. I need to mark it. A, B, C, F is a cyclic quad. So there's my situation right there. There's my situation right there. There's my situation right there. And there is my situation right there. Fine. Then it says with AB equal to BF, I think they put those strokes, I can see them. And AF and BC both produced meet at E. So I see that. F1 is equal to X. That I'm given. So there's my F1 is equal to X. And the tangent, and note these important words, and the tangent to the circle at F meets BE at D. That's fine. No problem. Give with reasons, 9,21. Give with reasons, two other angles equal to X. Give with reasons, two other angles equal to X. I gotta see this. Notice something interesting here. This X happens to be opposite AB. And I know that AB and BF are equal. So angle A is opposite BF. All right, I see that. So angle A is opposite BF. And BF and AB are equal. And F1, which is X, is opposite AB. So keep that in mind. Let me say that again. F1 is opposite AB, fine. That AB is equal to BF, fine. And then the angle A is opposite BF. So I know a theorem. So for me, A becomes equal to F1 becomes equal to X. And here's my reason. Angles opposite equal sides. There you are. Angles opposite equal sides. So I've gotten my first X. So in this case here, I know that all angles opposite equal sides. So this angle is X. Somebody raised up their hand here. I will unmute you. Go ahead.
Morning, sir.
Morning. Hi.
Hello.
I can hear you.
Sir.
Yes.
With a question like this, would I be wrong to state the reason after writing that saying properties of an isosceles triangle? Is that the reasoning wrong?
You'd be fine. You'd be fine. That reason is very much accepted. So properties of an isosceles triangle, someone can opt to say base angles of an isosceles. So for me, I would take those kind of scenarios. So that's okay. Thank you for that. I need my other angle equal to X. I need my another angle equal to X. C2. C2 is equal to XA is equal to C2. Okay, what are you saying, Say? Are you saying C2 is equal to X? Yes, I am. Why? Because this is exterior angle of a cyclic quad. Write that one down. Exterior angle of a cyclic quad. 9,22. We're going on 9,22. It's a good 5 marks. We need to think. 9,22. It's a good 5 marks. I'm going to take this out now within the next coming couple of seconds as we learn more and more. All right, get ready for 9,22. Express F4 in terms of X. Express F4 in terms of X. Okay, this one is going out now. Gone. All right, let's think, family. Let's think on this one. Express F4 in terms of X. So I'm supposed to express this guy, and it's 5 marks in terms of X. So I need to start thinking within myself. All right, let's start this way. You see, F3, let's start this way. F3. In the exam, guys, I need you to try your best to think as far as you can. Look at what's related one to another. So I'm looking for F4. That's what I'm looking for in terms of X. Now, if I look at F3, F3 is equal to B2. Okay, I need to write all the information that I can see. Maybe it will help me. F3 is equal to B2, and that for me is turn-chord theorem. That's fine. Fine. So what? So what if F3 is equal to B3, right? Equal to B2 rather. F3 is equal to B2. Now, notice something interesting as well. F3 plus F4. Okay, let me extend this. There you are. F3 plus F4 is equal to B1 plus B2. Okay. Why? Exterior angle of a cyclic chord. Okay. So F3 plus F4, okay, there it is equal to B1 plus B2. There it is. These are exterior angle of a cyclic chord. So I need to write that information. So F3, all right, plus F4, remember I'm looking for F4, is equal to B2 plus B1, right? Exterior angle of cyclic chord. Let me see how that's going to help me. Now look at something. Previously, we said F3 and B2 are equal, previously there. Okay, you know what that means automatically? It means F4 is now automatically equal to B1. So if F3 is equal to B2, then F4, look at it, F3 plus F4 is equal to B2 plus B1. So these guys here, the F3, right? Yes, the F3 and the B2 are already equal. That means F4 becomes equal to B1. By extension, just by looking at this, I can tell you that F4 will be equal to B1 since F3 is equal to B2. Fine. So what? When I'm looking for F4, so what? Now, go back to this triangle. Let's go back. Let me show you something interesting here. Visit triangle ABF. Let's visit triangle ABF. Notice that I know that A is X. I know that F1 is X, and I can find B1. If I find B1, automatically I found F4, because that's what I'm looking for. Check this out. If I find B1 in triangle ABF, then I have found F4, which I'm looking for. Let's do some logic here. So in triangle ABF, what's happening? A as an angle plus F1 as an angle plus B1 as an angle, they equate to 180 angles in a triangle. X for angle A, F1, X, B1, I'm almost there. All right, there we are. B1 is equal to 180 minus 2x. I'm not looking for B1. I'm looking for F4. So F4 at the end of the day is equal to B1 is equal to 180 minus 2x. 5 marks. That's how we think. So you must be able, in such cases, think about what you're looking at. Like, okay, what do I see? What's common? They say cyclic chord. What's going on? Who's equal to who? Start thinking along those lines. You'll be able to end up seeing what's really going on in this particular case. So that's your answer. F4 is equal to B1 is equal to 180 minus 2x. Okay, I'm ready for 9,23. Write this down, family. Write this down, and I'm ready for 9,23. Right? 9,23. All right, I'm ready for my next one. Let's try that one. Okay, so that's a beautiful question that we just did now. We can pull through and see how far we go. Let me try the next one quickly on that one. All right, so there we have it on 9,22. Express F4 in terms of X, and I'm taking this out. Let's try 9,23. Okay, Mahlodi, raise your hand. Let's see how far you need. I'm ready. Let's go. Talk to me. I've unmuted you, so you should be able to say something.
Hello.
Go ahead. I'm here. Yes.
Yes. Oh, I'm kind of lost. Like 9.2. Can you like explain it again?
9.22.
Yes.
Okay, let's try that again. In essence, what I'm saying, you can mute yourself in the meantime. In essence, this is what I'm saying, guys, and I think you guys need to pull this through. Don't worry, you will be okay, right? You're looking for F4 in terms of X. Take this out, take this out, take this out. You're looking for F4 in terms of X. Keep that in your head. F4 in terms of X. What do I know? F3. F3 is made from a tangent, FD, and it touches the chord FC. FC subtends B2 at the circumference. So F3 is equal to B2, tan chord theorem. I mark that, tan chord theorem. That's what I can see. So what? We're told that there's a cyclic chord, ABCF. ABCF is my cyclic chord. If I consider this cyclic chord, then I can tell you that F3 plus F4, I'm now joining stuff together, will be equal to B1 plus B2. Exterior angle of a cyclic chord, this one, is equal to the interior opposite angle, that one. That's my statement right there. So F3 plus F4 is equal to B2 plus B1. But notice the following. Did we not see or say in the previous question, or in the previous statement rather, that F3, there's F3, is equal to B2? That's what we said. So this F3 right here is equal to B2 right there. Guys, it's like saying this, 20 plus B1 as an example is equal to 20 plus B3. You know what it means? 20 is equal to 20. It means B1 is equal to B3. That's basically what it means, right? So if this is equal to that one, automatically that one is equal to that one, because it's just equal to, they're adding anyway. So for me, F4 becomes equal to B1, which is my statement right here. Fine, B1, let's go to B1. I don't know what B1 is, but I think I'm winning on B1. If I consider this triangle ABF, if I consider triangle, and I'm just going to draw it here, triangle A, and then a B, and then F as well on that triangle. Notice that if you were to add A there, plus F1 there, plus B1 there, we get 180 angles in a triangle. So at the end of the day, B1 is 180 minus 2x. But what is B1? It's F4. What are we looking for, Tina? F4. That's what it becomes at the end of the day. All right, let's pull through and see how far we go. Guys, I'm going to try my best to read your messages. It's just that it's just a lot of traffic that I need to be dealing with on this side. I'll try my best to read your messages. Right, okay, guys, I'm going to take this out. I want to try the next one, 9,23. Let's see how far we go. I think I see a message. I'm going to attend to it there. Prove that FB, where's FB? FB is a tangent to the circle passing through the points F, okay, the points C, okay, and the points and E right there. That's interesting. Prove that FB is a tangent to a circle that passes through points FC and E right there. Okay, sharp. So that tangent there, if truly FB is a tangent, you know what I can expect? Here's what I can expect. I can expect that since my circle, and I'm just gonna try and draw it here, that circle there, let's see if it'll come out the way I want it. It's not coming out the way I want it. No, it's not. All right, but either way, if I could have a circle between on the points F, C, and E, then I can quickly tell you that for me, F2 should be equal to angle E because of the tan chord theorem. If FB is a tangent, but that's what we need to prove. We need to prove that FB is a tangent. And proving that FB is a tangent suggests to me that F2 should be equal to angle E. That's what I'm looking at. F2 should be equal to angle E. That's what I'm looking at right there. If FB is truly a tangent. So what we need to do now, our task is to prove that F2 is actually equal to E. When we do that, we have proved that FB is a tangent by virtue of the converse of the tan chord theorem. Let me say that again. Normally with the tan chord, we draw an angle from the tangent. Let's say the tangent is FB to the chord, which is FC. And who does FC subtend at the circumference? Angle E right there. So we need to prove that F2 is equal to E in order to show that FB is a tangent. Let's see if we're on the right track. Follow my lead. All right. Or 9.23. Let's think now. Okay, so I know what I need to prove, so let me think now. Let's agree. F1, there's F1 plus F2. Okay. F1 plus F2 is equal to, check it out, C2 plus E. Here, let me draw these triangles. That's why I insist that in the exam, if you can get color pens, please bring them. Let me show you where I'm coming from. There we are, and then there we are. Look at this triangle. Okay, I want to show that F2 is equal to X. Look at this triangle. Right, I'm saying to you, F1 and F2, there they are. So F1 plus F2, okay, would be equal to C2 plus E. C2 plus E. Why? Exterior angle of a triangle. There it is. So F1 plus F2 is equal to C2 plus E. And I'm on triangle of triangle FCE. That's what I am on. All right. So that's where I am. But hold on. So how does that help me? F1 plus F2 is equal to C2 plus E. Did you notice that earlier we proved that F1 earlier is equal to C2? We proved it. Let me show you. F1 is equal to C2. We proved it earlier on. How did we prove it? Well, I remember in question 9.21, they asked us for two other angles equal to X. One of them was A, equals angles opposite equal sides. The other one was C2, which is X, because it was exterior angle of a cyclic quad. So I know that F1 is C2. Again, automatically, if this guy, F1, is equal to C2, then automatically F2 would be equal to E. So the angle F2 would be equal to angle E, and that's the jackpot right there. F2 is equal to E. So now I see the jackpot. Jackpot now tells me that angle F2, there it is equal to angle E. So dot there, let me put a dot there as well. So if that's the case, if F2 is equal to E, then we can automatically confirm that BF is a tangent right there. So BF or FB becomes a tangent, and my reason is converse of tan chord, the other way of saying the tan-chord theorem. Or you could say also angle between line and chord, proving to me that FB is a tangent to the circle that could pass through F, C, and E. For marks, obviously, guys, I started off with easy questions. I'm upping the gear right now here. Gears up. There we go. I'm ready for my next one. Let's up the gear a bit. And then I'll give you some stuff to do later on. Let me do one more question because I started off with part 1, which is grade 10 and grade 11. And so let me do one more question on grade 10 and grade 11. Then after that, I'll do the grade 12 part in our lesson. All right, we're left with over an hour, think slightly over an hour. So we need to utilize every single time that we have. Write this down, family. I want to take this out. Write this down. I'd like to take this out. So this is going. There it is. All right, moving on to my next question right there. That's where I'm moving on to my next question. So this one, I won't do it. I want you guys to do it, and I'll give you time for that. Let's go to 2010 March, paper 3, question 9. Let's try that particular question together. 2010 March, paper 3, and that's question number 9. So don't be overwhelmed. Don't give up. You know, we can make it. That's why we learn, okay? So that when we get to points, we can pull through and from that level. Okay, somebody sent a message now and says, say, am I correct to say F4? Okay, let's see what you're talking about. F4 there is equal to F5 there, right there. And you're saying your reason is what? Vertically opposite angles. And then you say F5 is equal to B1. And for that one right there, it would be because of tan-chord. Well, the last part, which is F5, is equal to B1. I would definitely take that. But I don't know what it will help me with in what I'm doing. Then the F4 equal to F5, then vertically opposite angles. Let me see what you're talking about there. F4 and then F5. Let me see the other one. F1 should be equal to, no, that won't be correct. Look at the lines. There's 2 lines that are messing things up. This line here and that line there, right? So it won't be correct on that one. So I don't know to what end, but that basically, for F5 equal to B1, then definitely I would agree on that one. All right, let me move quickly to my next one so that I don't have to waste time. Thank you so much for the questions, guys, are amazing. Let's keep working. Complete the following statement. 2010 March, paper 3, question 9. The angle between the tangent and the chord, there you are, dash, 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 dash. Obviously, guys, when they ask you to finish this statement, it's because eventually in the question itself, you're going to use it. So it's important to remember that. So it says to me, the angle between the tangent and the chord is, write the following, equal to the angle subtended by the same chord, equal to the angle subtended by the same chord in the alternate segment, equal to the angle subtended by the same chord in the alternate segment. That's tan-chord for you. That's the full tan-chord statement. Again, equal to the angle subtended by the same chord in the alternate segment. 9,2, here we go. In the diagram below, 2 circles have a common tangent, TAB. So let me look at it, TAB. There's my tangent. And it says PT, there's PT, is a tangent to the smaller circle. So there's my smaller circle, which is PAQ. So P, to the smaller circle rather. Then it says PAQ, let me look at it, PAQ, that's a straight line. QRT, let me look at it, QRT, that's another straight line. NAR, let me look at it, NAR are also straight lines. And then let Q be equal to X. So I think on the diagram itself, they showed us Q as X. 9,21, 5 marks. Name with reasons 3 other angles equal to X. Name with reasons 3 other angles equal to X. All right, let's discuss. Judging by what I'm looking at, there's my X right there. Who else should be equal to X? A2. This angle, A2. Tan-Cot theorem. That's the first thing that they asked us anyway. A2 is equal to Q is equal to X. For me, that's the Tan-Cot theorem. Fine. Let's see the other one. Who else? They want 3 of them. I already found one. A2. So A2 is my first guy who is equal to X. So that's A2. Let's try and see if I can get something else as well. A5. A5 is definitely equal to X. Let me confirm that with you. See, I've got PQ as a line. I've got NR as a line, which is what the previous student asked me about the question about vertical opposite. I said no. Here it's easy because I only have 2 lines that cross each other. So I can tell you that A2 is equal to A5 right there. And my reason is vertically opposite. So A5 is equal to A2, which we know is equal to X. It's vertically opposite angles right there. Then let me see my third one, because they want 3 of them. I think I'm going to win on the third one pretty well. I'm going to look at the smaller circle. I'm going to look at the smaller circle. I'm going to look at A5, which I know is X. I know A2 is also X. Then I can tell you that P2 is X. Again, my reason, Tan-Cot theorem. So P2 is equal to A5, which we now know is X. Then it's going to be the Tan-Cot theorem. And I get my 5 marks right there. So P2 is equal to X is equal to A. That's my Tan-Cot theorem right there. It's my Tan-Cot theorem. All right, let's try our next one. Let's try our next one. Five marks again. 5 marks. The next one. Okay. All right, let me know if I'm still loud enough and all that. So someone says, say, will it be incorrect if I say it P1? Let me see if I can see what you're talking about. P1, there's P1, is also, if I say P1 is also X tangents from the same point. See, the problem is I said A2 for me. I said A2 is equal to A5. And then I also said P2 is equal to X. Let me write my X as X. This one will be X. This one will be X. So are you suggesting to me that P1 is also X because it's tangents from the same point? Not necessarily. P1 will be equal to A3, but A3 is not X. You see? A3 is definitely not X at all. So P1 is definitely equal to A3, your reason, tangents drawn from the same point outside a circle. And I think I'm going to use that for my next question right there. Let me go quickly. Prove that APTR is a cyclic quad. So I need to prove something here. Prove that APTR is a cyclic quad. Follow my lead. A, where's A? There. All right. P, there's P. All right. Then T, I'm going to draw it up to T. And then there's R right there. And then there's something like this. Okay, so prove that that shape is a cyclic quad. Now, let's get what the problem is here. Normally, when you see a cyclic quad, you're looking at a shape where all the points are on the circumference. In this case, it's not true. So we can't really say it's a cyclic quad according to what we know. We can only say it's a cyclic quad if they tell us, and we're supposed to prove that. We're supposed to prove that that shape that they told us is definitely a cyclic quad, all right? That's what we're supposed to prove. And I'm okay with that particular situation as it is, right? Then what do I need? What do I need to do to prove that a shape is a cyclic quad? 3 things. Here's how you prove that a shape is a cyclic quad. Either of the 3 things, whichever one works in your circumstance that you're dealing with. Number 1, you can prove that the opposite angles are supplementary. In other words, if you can prove that opposite angles within that cyclic quad are supplementary, then you've proved that that shape is a cyclic quad. Number 2, you can prove that the exterior angle of a cyclic quad will be equal to the interior opposite angle. That's the second way of proving that a shape is a cyclic quad. So number 1, prove that opposite angles are supplementary. If you can, then that's okay. Can you prove that exterior angle of a cyclic quad is equal to the interior opposite? If you can, that's okay. And then thirdly, can you prove that within the cyclic quad, at the vertices, listen to me, you'll watch this later on YouTube as well. Listen to me. You can prove that within the cyclic quad, at the vertices, there are angles subtended by the same chord. Or rather, you can say at the vertices of a cyclic quad, there are angles in the same segment. So here's the third way, angles in the same segment. You can prove that. So if you can prove any of these 3, then you can prove that a shape is a cyclic quad. Right at the vertices are the sharp points, those points at the end of a shape. So angles in the same segment. 3 ways of proving that a shape is a cyclic quad. Let's deal with our scenario. What do we have in our scenario right now? So let me see what I have right now in this particular scenario. I need to prove that APTR is a cyclic quad. Let me gather my information. Let's go. First thing, PT, the side PT is equal to TA. I can see that. So this side PT is equal to the side TA. Why? Because these are points drawn from the, or rather these are sides drawn from, in fact, these are tangents drawn from the same point. I'm trying to find my English there. Tangents drawn from same point outside a circle. So that's fine. So PT is equal to TA. Automatically, which is what one of you was saying, P1 becomes equal to A3 because these are angles opposite equal sides. I'm trying to prove that APTR is a cyclic quad. Follow my lead. So let me see. So P1, I'm going to put a tick, is equal to A3. I'm also going to put a tick, right? Okay, let me use A. Let me use A as a letter A instead of putting the ticks. It becomes easier. So P1 is A, and also A3 is A. A6 is also A. A6 is also A. So I'm gathering my information. A6 is equal to A3, right there. Y, vertically opposite angles. So what? I'm trying to prove that APTR is a cyclic quad. So A6 is equal to A. Okay. This is what I can tell you. A6 is called R2. Okay. R2. Y. Turn code. Okay. So let me see what's going on here. So A6 is called R2, and that's the turn code theorem. Excuse me, guys. All right. So A6 is called R2, is called to turn code theorem. That's the reason. So then what? So look at it. So it means R2 is equal to A as well. That means P1, which is A, It's called other 2, which is also A. And other 2 is outside. It's outside. And it's other 2 and P1 are opposite. That the exterior angle of a cyclic quad, other 2, is equal to the interior opposite angle P1, right there. Other 2 is equal to P1. Exterior angle of a cyclic quad. Okay, I'm looking at something. Okay, use numbers. All right, use numbers. Let's not use A. Use numbers. Let me show you how interesting it becomes. So in the exam, try to avoid using P1's quad. Use numbers. Imagine the P1 was 20. That means A3 is also 20. That means A6 is also 20. That means R2 is also 20. R2, which is 20, is equal to P1, which is 20. And then automatically, R2 is outside exterior angle of a cyclic quad. So therefore, R2, this one here, would be equal to P1, that one there. And then we can say to ourselves, APTR is a cyclic quad, and it's converse of the exterior angle of a cyclic quad right there. So you can see that R2, by virtue of being 20, I'm trying to use numbers, will be equal to P1, which is also 20. And look, judging by their positions, R2 is outside exterior angle of a cyclic quad, P1 is inside interior opposite angle. And what we know from that theorem is that the exterior angle of a cyclic quad is equal to the interior opposite angle. All right. There we go. That's your question. 5 marks. Yeah, it's fire. It's fire. Let's try more. Let's try more as a family. Let's try more. Let's see if we can get this right. Let's try some more as a family. All right. Hoping you guys are understanding and seeing what I'm doing. I'm going to try again, a couple of more questions, and we'll end it up at about 11 o'clock. So I'll add an extra 15 minutes so that we are guaranteed that we're on the right track. So it means that we're left now with an hour. Decided to add another extra 15 minutes and take it out from there. Okay, Gugu, you raised your hand. I would like to unmute you right now. Let's go, Gugu.
Say hi. Hello. Okay, I need to already know R2 is X.
No.
So can you hear me?
Yeah, I can hear you. R2 is not X. It was
R2.
A2, which was X.
It
was A2, which was X.
Yeah.
Right? Let me show you what I mean by this. So R2 is not X. It was A2, which was X. And then we said also A5 is X. And we said also P2 is X. You see that? So R2 is not X. I don't know what it is. It's just going to be equal to A6, A3, P1. I'm just working backwards. Talk to me, Gugu. Okay, what did you want to tell me?
Oh, I mean, I thought R2 was X, and then I calculated for R1. Then it was 180 minus X, and then I added with P1, and then it's going to be X plus X. 180 minus X plus X, then X is going to cancel X, and it's going to be 180. Then
but again, you see what the problem with that, Gugune, is you're assuming that P1 is also X, which is not. P1 is not X. You see, it would have worked if P1 was X, your method, it would have worked. Look at my blue signs on my diagram, those blue signs. They actually tell me that those blue angles, X, 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 those are the only guys that are equal to X, including Q, which were given. So yes, if it was like that, then I would agree. But it's not like that in this scenario. All right. So much for that one. I'm moving on to my next one. I'm hoping that people have written this. Let me give it a couple of seconds so that we can pull through together as a family. All right, going. There we are. I've taken that one out. Right, let me try another question. This time, allow me to start here. I want to do the grade 12 ones now. The line parallel to one side of a triangle, and then also proportionality theorem. So we'll start off on something like this, which is not too difficult, and we take it up from there. Okay, 2014 standard grade paper 2, and that's question 10. Paper 2, question 10, please write that one down. You notice that I skipped some questions. Those ones you can probably do. I won't be able to do all the questions, but I would have loved to. In the diagram below, AD is a diameter of the circle ABCD. So AD is the diameter of the circle ABCD. So I see that. BC is equal to CD. I can also see that from the diagram. PD, there's PD, is a tangent. I must keep that in mind. PD is a tangent to the circle at D. Then APB is a straight line. I also see that AC produced meets tangent PD at E. Let B2 be X. I'm adding my stuff here. Let B2 be X. Okay. Write down with reasons 4 other angles that are equal in size to X. All right, I need 4 angles equal in size to X. I need help. So let me write my 4 dots because I'm going to write my 4 angles right here. Here we go. B2, I'm given as X is equal to D2. Okay, is equal to X. Angles, opposite, equal sides. Okay, I'm fine with that. I'm winning. Okay. D2, who subtends D2? CD. So the line or the angle D2 is made by the line CD, CB rather, not CD, CB. So D2 is made by the line CB. Who does CB make it the circumference? A2. So if this guy is X, O, D2, that means automatically that A2 is also X. So then for me, A2 would be equal to D2, which is X, and these are angles in the same segment, or you could say angles subtended by the same chord. Fine. Look at B2 again. Look at B2. B2 is made by CD. Okay, so a line from C and a line from D makes B2, which is X. CD also makes angle A1 at the circumference, right? So A1 is also X now because angles in the same segment. Remember, I already said A2 is X, right? So for me now, A1 is equal to that B2 is equal to X as we know it. It's the same reason, angles in the same segment. I'm looking for my 4th one so that I can get my 6 marks. Okay, so who's the 4th one? Let me use a different color pen. D3, look at D3. D3 touches the chord CD, and D3 is an angle from the tangent to the chord CD. CD subtends A1, which we know as X. So then I can say D3 is equal to A1 is equal to X. For me, tan chord theorem. I get 6 marks right there. Tan chord theorem. I get 6 marks. Beautiful. Get tan chord theorem. All right, write this down. Let me know if there's any struggles there. See, Euclidean geometry again, guys. Let me tell you how you get it. Practice. Yeah, I cannot overemphasize the need for practice. Practice makes it perfect. Without practice, there's no perfection. All right, I'm ready for my next one. Let's try and see. Let's try and see my next one right there. Okay, so this one is going. There you are. Mahlodi says, say, please explain second point. 2 reasons confuses me. Mahlodi, can you just unmute just lift up your hand and I get to know what you are asking me so that I have an idea of what you need. Just raise your hand. There you are. And then I'm going to quickly unmute you. Go ahead. Please go ahead. Go ahead, Mahlodi. I've unmuted you. Not winning with you anymore.
Hello.
Yebo.
Yes. So the second point says A2 equals to D2 equals to X. But then you gave 2 reasons. Like the first one says angles subtended by the same chord. And the second one says angles in the same segment.
It's the same thing. Whether you can say angles in the same segment or angles subtended by the
Yes.
same chord, it's the same thing. Yeah.
Okay, thank you. Thank you.
All right, sharp. Okay. All right, I'm done with that one. Here's we go. Prove that ACD, all right, so that whole ACD situation, right, is similar to ADE. All right, so here's what I advise you in the exam. When they give you similarity, the only way that 2 triangles can be similar is when their corresponding angles are equal. So here's my suggestion. Follow it nicely. ACD. So let's go to ACD first. A, all right. C, okay. And then D. So who's A? ACD. That's, okay, let me put it in a different color pen. That whole triangle. You guys can see what I'm talking about. So I've got this part here. A, okay. C, all right. And then D. Let's follow that triangle. Right, so I'm going to write the angles that I see there on that one. So I've got A1, ACD, okay? I've got AC, C2, I've got that, and then CD, and then for D is D1 and D2. So that's what I'm looking at, D1 and D2 for that one. Right, let me go to ADE. Let me try and use a different color pen to show that particular triangle. ADE, follow my lead. I'm showing that triangle. AE, all right. And then D, okay. So it's going to be this one here. So let me just draw it, put underneath there. And then A, D, E. So there you are. And that one, the other one. So it's ADE. Follow those ADEs. Who's A? AE, I think that's A1. Okay, there you are. D, A, D, E. For me, it's D1 plus D2 plus D3. That whole thing. Then E, for me, it's E1 right there. So that's how I want you to do it. Specify the angles of concern in your triangles. And these angles, as you wrote them down, should be equal. So your task is just to get the reasons why. The reasons why they are equal, that's all. So look at it. A1 is called to A1 because it's a common angle. We love this reason. So fine, we've gotten our first reason. A1 is called to A1 common. Let's look at C2. C2 is called to D1 plus D2 plus D3. Why? Now, notice the following. C2 is actually equal to 90 degrees. And I have a reason. Why? It's because it's angles in a semicircle. That's what C2 is equal to 90. Fine. Say, are you also saying D1 plus D2 plus D3 is equal to 90? Yeah, I am. How do you know that? What is your reason? Where do you get that confidence from? That D1 plus D2 plus D3 is equal to 90. This is a diameter perpendicular tangent. Exactly. The diameter is AD, and then there's that whole tangent PD. And where they meet at D, that whole angle D, which is D1, D2, and D3, is 90. It's diameter perpendicular tangent. So I'm going to have diameter perpendicular tangent. So in other words, C2 and D1 and D3, both of them are equal to 90. We've proved it. Both equal to 90 degrees, and maybe you can just say proved. So we already have 2 reasons why these angles are equal. The third reason, I don't need to think about it. You know what I say? I say third angle of triangle. So when you're proving similarity, all you need to do is just get two reasons, and then after that, the last one will be third angle of a triangle. Okay. So in this case, then I can simply say triangle ACD is similar to triangle ADE. What would be my ultimate reason? Angle, angle, angle. Or you can say they are equiangular if you want. So all the angles are equal, equiangular. That's how you prove that ACD is similar to ADE. Let's try another one and see how far we go. Let's try another one and see how far we go. Okay, so we're learning, we're gathering information. Let's try 10,22. My suggestion again, when you prove similarity, family, when you prove similarity, draw the triangles apart. The moment you prove similarity, draw the triangles apart. Prove similarity, draw the triangles apart. Okay, this I'm taking out now. I've proved similarity. I'm going to draw the triangles apart because it will help you for your next question. Right, this is gone. I'm drawing my triangles here, and these are my triangles, and I'm going to draw them nicely as I see them. All right, guys, when you're labeling them, guys, please be careful of labeling. ACD, follow it. A, follow that. C, and that D. Follow on the next one. ADE, A, then D, then E. Please be careful when you're writing them down. Fine. Look at 10,22, 2 marks. Prove that AC, there's AC, DE is equal to AD, it's equal to BC. So what do I do in such questions? Pick the size that they gave you. AC, start off with this one here, AC. There's my AC. AC goes with AD according to the theorem that says similar triangles are in proportion. So I can always say to myself, in this case, that AC over AD. That would be my first thing. So I've taken AC and it goes with this partner AD. And I happen to have an AD there as well. Let me look at the next one is DE. So that's DE. So there's my DE here. But my DE goes with my CD. All right. But where did I start off in this proportionality? I started off in this triangle number 1. Let me show you what I mean. AC over AD, right? That's what I said. Should be equal to, go back to triangle number 1. That's where you started off your ratios. Will be equal to CD, this one here, over DE, right? Because I have a DE, but I couldn't have started off from triangle number 2 because my proportionality, I started it from triangle number 1. So be very careful. Be very careful. So AC goes with AD, go back. CD goes with DE. And I need to have a reason. It's because similar triangles are in proportion. That for me is what's happening. Similar triangles are in proportion. Now let's do some cross multiplication. So AC dot DE, I'm winning. I'm looking like this side right there at the top. It's looking like that side is equal to AD, I'm cross multiplying, multiplied by CD. Okay, everything looks okay except this guy. Let me see. Judging by what they gave me, I think for me, and I'm just going to erase this a bit quickly. All right, I think for me, AC, I have it, AC there, DE there, DE there, AD there, AD there. CD. I've got BC, they've got BC, I mean I've got CD. But hold on, go back to the original diagram. Did you notice that CD is actually BC? They even gave us here. But BC is equal to CD and that is given. So ultimately, AC dot DE should be equal to AD. Instead of CD, I can write BC, and it's exactly like what they told me. So that becomes your answer. All right, 10,22, beautiful, that one. Try and draw my arrow there. All right, so again, guys, the moment you prove similarity, draw the triangles apart. The moment you prove similarity, draw the triangles apart. The moment you prove similarity, draw the triangles apart. All right, I'm ready for my next one. All right, this is gone. Okay, maybe someone is still writing, but I think this should be fine. Let me do my next question. Try that one and see how far I can go. Okay, there you are. Going to my next question, and it's 2010 November, paper 3, and that's question number 8,2. 2010 November, paper 3, and that's question number 8,2. Okay, I'm ready for my next one. Right there. ED is the diameter of the circle with center O. So I need to note there's very important things. ED is extended to C. CA is a tangent. So don't forget these words, tangent, diameter, blah, blah, blah. Very important that you remember these words nicely, and we take it up from there. All right. And then we take it up now to say CA is a tangent to the circle. Let me write the words that are very important. Diameter and then tangent. Okay, I think someone sent a message. I'll read it. Allow me to move on here quickly, and I'll read it and understand. All right. AO intersects blah, blah, blah. It's BE and F. BD is parallel to AO. I can see that. E is equal to X. Write down with reasons. 3 other angles equal to X. I'm ready. Okay, this is X. The first one, this is a radius, OB, because that's O is the center. Even O is a radius. So I can safely tell you that B2 is equal to E is equal to X. These are angles opposite equal sides. And those equal sides are the radii. So let me write radii. Okay. That's fine. So this is X. I gotta look at it. And then the other one is B4. Get it? Tangent, tan chord theorem. B4 touches the chord BD. BD subtends E at the circumference. So for me, B4 is equal to angle E is equal to X. That should be tan chord. I need 3. I've got 2. Let me see. Imagine if you're going to extend this line, BD. Imagine to extend, it's a parallel line. Let me use a proper straight line there. Let's extend this line, BD, there. And let me extend this line also as well with AO. I can safely tell you that B4, which is X, will be equal to A, corresponding angles. There you are. B4 is X, is equal to A. All right, or rather, let me say A is equal to B4 because that's what I'm going to write from. So angle A is equal to B4. That's why it's important to know these things. Is equal to X corresponding angles. And why am I saying that? Is because BD is parallel to AO. So once you write corresponding angles, you must be able to explain which lines are parallel to each other. So A is equal to B4 is equal to X. That's 8,21. Just want to read the message that came through from let's see, I think it's Mashori. Say, okay. Write this down, guys, while I try to reason with this. No, okay, no, it's not Maclod, it's Umutu here. No. You're saying, say, because that I found that triangle ACD is similar to ADE, I think it's the previous question. I said that AC over DE is called CD over DE, it's called AD over D without drawing the triangles. That's fine. But I honestly feel like you must draw the triangles, because sometimes they ask really complicated questions that you can't do unless you've drawn the triangle. So it's very important that you get that right. Okay, I'm now on 8,22, 8,22. You let me know, guys, if I took it out too fast. You raise up your hand. Don't take it out, say blah, blah, blah. It's free for all. Determine with reasons, CBE. So let me see what I'm looking for. CBE, who's that? CBE, this wall angle. They said in terms of X, 3 marks. Okay. So I'll write this down, CBE. For me, it's going to be B2 plus B3 plus B4. That's what CBE is, all right? But they want it in terms of X. All right, B2 plus B3, I'm looking at it, is equal to 90 angles in a semicircle. All right. So check this out. CBE would be equal to B2 plus B3, which for me is 90, plus B4, which we found from the previous question as X, right? And then at the end of the day, so 90 plus X. All right, somebody's asking a question. Say, how is B2 equal to E? Angles opposite equal sides. There's radius. The radius is OB and then OE. So B2 is opposite the radius. Angle X is opposite the radius. Angles opposite equal side. That's the answer, Rio. I think I can say that. Angles opposite equal sides. All right. 8,23. We're going now as a team, as a family. 8,23. Let's see how we can go on 8,23. 8,23. Let's see how we can go. Prove that F is the midpoint of BE, right? Prove that F, this point here, is the midpoint of BE. All right, guys, let's think. F is a midpoint. Let me use what I know. You see, this B2, B3 business is 90. That's for sure. F1, all right, plus B2, B3 is equal to 180. Co-interior angles, definitely, yeah. F1 and B2 and B3 are equal to, when you add them together, because I've got parallel lines, BD being parallel to AF. So F1 plus B2 plus B3 is equal to 180, co-interior angles. And B2 and B3 is 90 from the previous question we found it. Automatically for me, F1 is now equal to 90 degrees. So F1 is 90. But they want me to prove that F is a midpoint. So if F1 is 90, then now I'm winning. It means OF is perpendicular to BE. Check it out. Since F1 is 90, right? F1 is 90. So F1 is 90. That would be my reason. So OF is perpendicular to BE. Then I can tell you that BF is equal to FE, right? Because what? It's because line from center perpendicular to the chord, which is line OF from the center perpendicular to the chord BF, bisects the chord. So therefore, F is a midpoint. Yeah, that's what you have. F is a midpoint. So we need to think when it gets to these things. F is a midpoint. F is a midpoint. Okay, I got a couple of questions from the groups as well. Let me see what's happening. So somebody's asking, say, can you please explain 8,22? Not a problem. I can go back to it. Let's see. On 8,22, while others are writing this, and maybe someone can want me to do this again, I'll do it. 8,22, guys, this angle here is 90. Ne? Subtended by a diameter, a line from D and a line from E, because they told me that ED, right? ED is a diameter. So this B2, B3 is 90. We already found from the previous question that B4 was X, right? And so I'm looking for CBE, and CBE is the wall of B2, B3, and B4, 90 plus X. That's what it is. So that's 90 plus X. Then someone says, say with 8,22, how is CBE in a semicircle while CBE, semicircle while angle C is outside the circle? I didn't say CBE is a semicircle. I actually said B2 and B3 because CBE is three angles, B2, B3, and B4. So I concluded that B2 and B3 are 90 plus that X there for B4. So I think that same way I explained the previous one is how I can explain that. Okay, so F is midpoint. There we are. We are moving on to the next one. All right, F is midpoint. Okay, taking this out, we are going to our next question. All right, prove that CBD is similar to CEB. Like I was saying to guys, when you're doing these things, please write the triangles angles that are concerned. CBD, I want to follow C. There's C on its own. B, there's B4. D, there's D2. CBD is equal to who? CEB. C, there's C. CE, E on its own there. And then finally, CEB. So I think I'm dealing with B2, B3, B4. It reasons now. Come on. First one, all right. Then B4 is called to X. I already know that B4 is X, and I proved it. It was Turncott theorem, or you could say Turncott if you want to. The last one, third angle of triangle, good one. Then now you can say triangle CBD is similar to triangle CEB, angle, angle, angle. And again, like I told you, the moment you prove similarity, draw the triangles apart. The moment you prove similarity, draw the triangles apart. Prove similarity, draw the triangles apart. All right, 8,25. After this, guys, I want to give you something to do. Just to see if you're on the right track. We're left with about 28 minutes, so it's fine. Just to see that you're on the right track, we can, pull through together and see how far we can go. All right, I'm ready for the next one. I've proved similarity. I draw the triangles apart. So I got C, follow it nicely, guys. Please don't mess up on the following of the signs. So on the angle CBD is my next triangle now. Okay, let me see how I'm going to draw this next triangle. I'm going to have it as CEB. Prove that 2 or twice EF dot CB is called to CE dot BE. Okay, let's use what I know. Let's just use what I know. I don't have EF on any of my two triangles. I have CB though. So let me just use it. CB, which goes with CE. So CB for me right here over CE right there. So I have that CB there, even from the question that they gave me, CE. Then I have BD from this part question, And so remember, I started off on this one here. Question 1, this is question 2, or this is triangle 2. So if CB over CE, then I go back, I can say BD over EB. I must have a reason, similar triangles in proportion. Okay, let me just do some cross multiplication quickly, this side on that one. So then I can have this as EB multiplied by CB, and then I can have this as CE multiplied by BD. Judging by what I see, the right-hand side, my right-hand side, which is this one, CE dot BD, is the same like theirs. But the problem is the left-hand side. I have CB like them, but then I have EB, they have 2 EF. So what's going on here? I have EB, they have 2 EF. Let me go back to the original diagram. Let me see if I can make a plan. I have EB, they have 2 EF. There's the line. I have EB, they have EF. What did we say before? Remember what we said? We said F is the midpoint. F is the midpoint. So it means to me, my EB is actually twice EF. It makes sense. It means this line and that line. So the whole EB is twice EF. And it's because F is midpoint. So instead of putting EB now, all I need to put there where there's EB is twice EF. Dot CB is equal to CE dot BD, just like they asked me to do. Right. That's like they asked me to do. I think I see a question here. Tejo says, B4, say, would it be okay if I say B4 is equal to E proven? Yes, it will be okay, because we already proved it from the previous one. All right, family, that's what we have now. Let me give you some stuff to try, okay? Let me see if I can give you some stuff to try on your own here and see that you're on the right track. Okay, write this down. Let's see if you're on the right track. Some stuff to try. Let's see if you're on the right track. Right, this is going. There you are. All right, some stuff to try on your own there. Let's see if you can get this right. Okay, family, let's try this one here. No, let me start from that part. Yeah, I'd want this one here. This very question. So this will be your first question right there. I want you to try it quickly. I'm going to give you just a couple of minutes to do it. Then we see if we can revise it together. But I want you to actually try this question right there. So it's that Eastern Cape paper, and I want you to try it. Okay, go ahead. It's 8 marks in total. Usually they say 1 minute, 1 mark. So maybe it will be for us 8 minutes. Let's try that. But let me give you 6, try to see if we can work faster. I'm here, but I'm going to mute myself in the meantime. All right, guys, we're done. I think now we can try and see if we can get this right. Others are done as well. Let's see if we're on the right track together as a team. All right. So we're doing the 2017 paper right there. And as you can see for yourself, it's this one that says PR is a diameter to the circle PRSU. QU is parallel to RS and meets SP in T. So it says to me, write down with reasons the size of angle S. So angle S is 90, and that's because of the angles in a semicircle. Yeah, subtended by a diameter. Angles in a semicircle. So you can see angle S, this angle S is made by a line from R and a line from P, which is my diameter right there. Okay, that's good. Let's try the next one. 6 marks, and others, I think they were saying to me, say they got 4 centimeters for TU. I agree, it's 4. But let's confirm how you've gotten that right. So first things first, since we know that this is 90 degrees, T2 is also 90 because they are corresponding angles. So T2 will be equal to angle S, will be equal to 90 degrees. And we're saying they are corresponding angles. Why are they corresponding? Because they are parallel lines, right? And so you must always specify the parallel lines, which is RS being parallel to QU. All right. Then so what? Now, if that's the case, look at the following. You're told that the diameter is 20 centimeters, right? So that means QP, the radius, will be 10. And even QU will also be 10 because QU is a radius. So the whole of Q and U will also be 10. Even QR is 10. Fine. We're told that SP is 16. So SP is 16. So what? So it means to me, you see a line drawn from the center of a circle perpendicular to a chord bisects the chord. So I can safely tell you that point T is a midpoint of the chord SP. And SP is 16. That means TP will be 8 right there. So let's do some logic here. So we know that T is a midpoint, right? But let's do this. Let me write it this way. I can safely tell you that ST is equal to TP is equal to 8 centimeters. That is line from center perpendicular to the chord bisects the chord. So I'm okay with that. Right, then now we're looking for TU. I think if we find QT, we'll be done. So I'm gonna be in triangle QPT. Let me try that one. And then because of that, I can use Pythagoras theorem in that triangle. I can safely say QP squared, all right, is equal to QT squared, which I don't know, plus TP squared. My reason being Pythagoras theorem. QP is 10, 10 squared, QT, I don't know you, TP, right, this is supposed to be TP. TP is 8 squared. If I do my maths properly, QT, at the end of the day, my QT becomes equal to 6 centimeters. But I'm not looking for QT, I'm looking for TU. But QU, that radius, is QT, what I have, plus TU. Well, the radius is QU, which is also 10, like the other radiuses. QT is 6, TU, so TU is definitely 4 centimeters, as you guys said to me. All right, beautiful. Write that one down. All right, by show of raising of hands, I can see it from the platform. How many got that thing right? All right, there you are. That's nice. Good people, I see that. So your hands are up. I can see them. Oh, quite a number of you, eh? Very happy for you. All right, so that's fine. You can lower down your hand all of you. Okay, I can do it for you, but you can also do it yourself. There you are, lowering hand. I'm just gonna lower their hands. Or yes, everyone has lowered their hand. Thank you so much, family. All right, let me give you another one. I think there was a question that comes from Umpo. Uti, why is RS not equal to 10 centimeters? Because it is parallel to QU. All right, good question. I think you're confusing theorems, Paul. Let me clarify what it means. All right, so RS and QT cannot be the same. They're just parallel lines, right? They're just parallel lines. They cannot be the same. But one thing that they can be, and I can clarify this for you, one thing that they can be is that QT, right, is half of RS. It's called the midpoint theorem that you learn in grade 12. They're not equal, it's just half of RS. So it says a line drawn from one midpoint of a triangle to the other midpoint of the other triangle will be half the distance of the third side of that triangle that it is in parallel with. That's how it's going to be. So so in this case, it's not the same. The midpoint theorem would work very well in this scenario because you've got a line drawn from one midpoint to another, parallel to one side of a triangle, is half RS. All right. Or you could say RS as a midpoint theorem is twice QT. So yes, they cannot be the same. One is half the other is twice the other. All right. I'm giving you a question now, probably our last one right here on this one. Let's try this question. 2015 Free State Prelim Paper 2, question 12. Try that one. So there's a question coming here from Chantal. I need to go back to the diagram, Chantal. Okay, I'll check it out when I see the diagram because I can't take this out now. Okay, guys, just rather do this because of our time. I want to move quickly. Let's see how far we can go. So we're supposed to prove that these are similar, D-A-H, all right? So D is just D, A is just A, then H is just H, and then O is just O, and then also C is just C, and then H is just H. So we're supposed to prove that these guys are similar. I think for me, this would be common, all right? That's okay. Then why is A equal to C? You see the angle A is 90 because this is radius perpendicular tangent. So this would be radius perpendicular tangent. And then also why is D, that angle, right, equal to O as well? So what do you think? Right, is it D-A-H? They write it right, D-A-H, and then O-C-H, right, D-A-H. Here you can always say third angle of triangle if you want. Third angle of triangle, no need to waste your time on anything. Then I can say triangle DAH is similar, let me take this out, is similar to triangle OCH, angle, angle, angle. And that's it. That's how you get your 4 marks here. And let's try 12.26 marks very quickly and see if it makes sense to any of us. There, I'm on 4.2 right there. So once you prove 2 reasons, it's fine. And then from there on, you can take it up to the next one. This is going now. Gone, going. Gone. All right, let's try the next one. Guys, like I told you, the moment you prove similarity, family, please draw things apart. The moment you prove similarity as a family, please draw the things apart. So you prove similarity, you draw these things apart right here. Okay, so I've got D-A-H, D-A-H. I've got this one here, the triangle, O-C-H, O-C-H. And then I'm supposed to prove all of this, okay? Interesting. Now, notice the following. DA, right? DA over OC will be equal to AH. I'm just picking out everything. This is H. AH over CH would be equal to also DH, all this over OH. So I'm pointing across what I'm looking at, right? So all these 3 sides for each particular triangle, they are in proportion. So I can say similar triangles in proportion. That's what I can say. Then look at it. I'm just gonna pick from what I have. I've got OH, so there's my OH. So I'm gonna pick this guy with the OH. Who else do I have? So I have the OH from that one. OA, don't have OA. DH, I have DH going with OH there. DC, I don't have DC, right? But look at it. Did you notice from the diagram that DC is the same like DA, tangents drawn from the same point? So I'd rather pick this one, right? Tangents drawn from the same point. So I can safely tell you that DA over OC in this case is equal to DH over OH. Let me make OH the subject of formula. So I'm going to cross multiply OH DA is equal to DH multiplied by OC. Then I can make OH the subject of the formula. That becomes DH dot OC, all this over DA. That's fine. So this is DH. But it's not what they have, right? Definitely not what they have. Let's agree, right? First things first, OC is equal to OA. OC is called OA, radii. There. So where there's OC, I can put OA, and there's OA in what they want. So first thing, we use a different color pen. So OC is equal to OA and those are radii. So it means now where there's OC, I can put OA, right? Let's go further. Then DA, so there's DH there, because I have DH. DA, okay, I can write it here, is equal to DC. And I can say tangents from same point, right? So that's fine. So tangents from the same point, let me erase this. So tangents from the same point. Okay, judging by what I see, OH becomes DH. I have that, they have that. OC, which is OA, all this over DA, which is now DC. And that's how you get your 6 marks. That's all. That's what you need to do. Who got this right? Let me see. Right, so that's what you have right there, and we're good to go. Okay, family, let's, Linde, you raised up your hand. Let's have you come through now. Okay, you put it down. Oh, I think you said you got it. Oh, that's great. That's lovely. Okay, family, I want to take this out within the next 30 seconds or so. So get ready to write as quickly as you can. All right. Thank you so much, guys. You've been wonderful today. Thank you for coming through to our lesson and everything that you did. So we're done with our lesson right now. Let me just say one more announcement very quickly. Just one more announcement, which is what I'm going to be doing, right? Eventually, I'm going to be doing this next month, which is me taking you guys through for a revision program. I'm excited about this. It's going to be 1,200 each subject, face-to-face, 8 hours a day. That's what's going to be happening. 3 days for each subject. It's going to be intense. You have not seen me on fire as you will see me when I do this one. So guys, talk to your parents if they're interested. If you're interested, the others are trying to make a payment plan. That's fine by me, but you need to talk to me. Talk to your parents. Let them talk to me. I've got limited space only, and it's filling up pretty fast. So book now and let's take it up from there. Otherwise, guys, thank you so much for coming through today. I will end our particular lesson now, and then I will upload this on our YouTube channel, and then we'll take it up from there.